This is the first of a series of lectures on the discipline of psychology, which was ironically referred to by William James as that nasty little subject. It's a subject of great variety and complexity, and even in the course of 48 lectures, it's going to be very, very difficult to convey all of that richness, complexity, and subtlety. The right way to begin something like this, I guess, is to define the subject, but here the standard texts are not particularly helpful. Open up any one of them, and what you're likely to discover is that psychology is the science of behavior, or a behavioral science. It's the science of the mind and mental life, as William James put it, the science of human and animal behavior, adaptive behavior, and the like. These are standard stock textbook definitions, which actually beg the question and don't answer it, namely, what is it about psychology that is or could ever hope to be a science? And indeed, what is it we have in mind when we refer to any body of knowledge or systematic study as scientific? Most of us, I think, had our thinking corrupted on this subject very, very early on. I recall in my own preparatory schooling that we were told what identifies something as scientific is that it employs the scientific method. And I must say, I probably spent about 25 years trying to find out just what that method was. There must be some method. It was searched for high and low, but there didn't seem to be anything that united what biologists do to what chemists do, to what physicists do, to what theoretical physicists and astrophysicists do, botanists, geneticists, and the like. A veritable riot of methods characterized these enterprises, and yet all of them were subsumed under the general heading science. Now, it obviously isn't enough to say, well, it's scientific if whoever is doing it is wearing a white coat, or it's scientific if whoever is doing it is careful in measuring things. If you go in to get a new pair of shoes, I guarantee you that the salesperson will use a ruler and take precise measurements of the length of your foot. We certainly wouldn't look down and thank this person for engaging in the noble pursuit of science merely because there was an attempt at accuracy or precision. Now, as with most of the issues that animate the house of intellect, there are no final answers to questions of the sort, what is the signal characteristic of science, what makes it different from everything else. But historians and philosophers of science have devoted productive labor to this question and have come up with some, at least tentative positions on the subject that are worth considering. One of the most influential, at least throughout most of the 1950s, one of the most influential in its effects on psychology and the thinking of psychologists, is a theory about science that identifies science according to the nature of the explanations that it provides. That is to say, an undertaking is taken to be a scientific undertaking when it can provide what are called scientific explanations. So now the question becomes not so much, is X a science, but does the activity X yield a scientific explanation? So we turn then to the issue of what it is that would make an explanation a scientific explanation. Now, I should think one of the leading writers and thinkers in this field, certainly through the 1950s and early 60s, was the philosopher of science Carl Hempel, very often identified as the chief spokesman for or interpreter of what is sometimes and rather misleadingly referred to as the nomological deductive model of scientific explanation. Let me try to break that term down. Nomological, from the ancient Greek for the word law, which is nomos, and what a nomological deductive model of explanation is this. You explain a phenomenon or an event of any kind by showing that it is an instance of a universal law known to be true. So let's take the standard example of someone dropping an object, taking a piece of chalk and dropping it, or dropping a shoe on the floor. There's an event now. And the question we ask is, how would you get a scientific explanation of an event like that? Now, this is what the nomological deductive model of explanation argues for. You explain an event like that by referring to Newton's universal law of gravitation. The universal law of gravitation is this. All objects, said Newton, he was quite young when he said this, by the way, all objects attract each other with a force that's directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, if you take the shoe to be an object, and if you take planet Earth to be an object, each of them now has mass. And the shoe and planet Earth will attract each other with a force proportional to the product of the mass of the shoe times the mass of the Earth, and inversely proportional to the square of the distance between the shoe and the gravitational center of the Earth. Now, if that law is true, then the answer to the question, why did the shoe fall toward the center of the Earth, is it had to. That is, it did what it did necessarily. The right answer to the question, then, is not things like shoes always fell when I dropped them in the past, and therefore there's no exception. I dropped it this time and it fell. Note, that's a generalization based on past experience, and that's not what the nomological deductive model requires of a scientific explanation. Not a generalization based on what happened in the past, but reference to a general or universal law known to be true, such that this event had to happen the way it did, precisely because this event is an instance of the class of events covered by the law. Well, now, if it really is the case that what renders an activity scientific is that it's able to provide scientific explanations for the events it seeks to study, then, of course, we seem doomed at the outset if we refer to psychology as a science, because the question that naturally arises is, what universal law known to be true operates in the domain of psychology? Is there anything as unfailing in its influence as the universal law of gravitation when we consider such things as human emotion, motivation, conscious states, life projects and plans, infant-mother relationships, interpersonal influence, all the things that fill out the panoply of psychological interests, concerns, and studies? There isn't a universal law to be found in the whole house. And of course, the same might be said, with all due respects to other sciences, the same can be said of biology, biochemistry, anatomy, physiology. There are very, very stable relationships that have been developed in these fields, but surely nothing of the precision, reliability, and unfailing nature of the laws in classical physics. Now, Hempel, of course, quite understands that very, very few scientific undertakings ever culminated in a universal law of the reach and precision and reliability of the gravitation law. So Hempel made a distinction then between a full-fledged scientific explanation and what he referred to as an explanation sketch. Now, the difference between a full-fledged scientific explanation and an explanation sketch is just the difference between a universal law known to be true and a very reliable statistical law. In economics, for example, there's this frequent reference to the law of supply and demand. Now, the law of supply and demand is not undeviating the way the universal law of gravitation is, but there is a quite systematic relationship between supply and demand. So on the what might be called the Hempelian account or the nomological deductive account, one can say that although economics does not have a universal law known to be true, there are trends and tendencies that have been discovered by economists, and these do allow reasonably good predictions. You don't have a full-fledged explanation in the Newtonian sense, but you've got a good explanation sketch. The question that arises then is, how good a sketch is it? Well, the quality of the sketch increases as the reliability of the law increases. The more reliable the general law, the statistical law, that is, the greater your accuracy of prediction, well, the higher the quality of the sketch. Now, one requirement here, of course, is that the law has to be true, and this for the obvious reason that a false law explains nothing. So now the question that surfaces is, well, for goodness sake, how do you know that a universal law is true? And what would you be prepared to say just in case at some later time a law you took to be universally true turned out to be not true? And in fact, the example I offered, the Newtonian law, the law of universal gravitation, is one of those. Newton's laws are based on certain assumptions about the constancy of mass and the constancy of momentum and the like, which after Einstein we come to understand are assumptions no longer warranted. So that in fact, as an object approaches the velocity of light, its mass increases, its linear extent diminishes. And therefore, if the universal law of gravitation presupposes that mass never changes at any velocity, well, at relativity velocities, of course, mass is changing, and the law would be wrong. Not only that, but the entire conception of reality is quite different in an Einsteinian universe versus a Newtonian universe. So I say, suppose at some later time, let's say after Einstein, what you thought was a universal law, utterly true, turns out to be not true. Well, read in a certain light, what Hempel's philosophy of science would require you to conclude is that all of the explanations you had offered on the basis of a law you now know is not true were not simply wrong explanations, but in fact they could not be scientific explanations, because a scientific explanation is based on a universal law known to be true. This, I submit, is one problem with that model. We would scarcely be inclined to say after Einstein that whatever it was Newton was up to not only failed to take into account what Einstein later discovered, but therefore it wasn't scientific. And I don't think Hempel would want to make that argument either. The argument instead would go something like this. The Newtonian worldview is valid within a certain context, the context of fair to mid-size objects traveling at calculable velocities. But it's only in the relatively rare context of entities approaching the velocity of light that the nature of the game changes, and that you would have to make relativistic corrections. So you wouldn't be dismissing Newton's achievement from the pantheon of science. You would say instead that the Newtonian worldview is bounded by certain conditions that do obtain under ordinary circumstances, but do not obtain under those conditions that we refer to as relativistic or relativity conditions. Now, how does one set about to determine whether or not a law is true? Every time the Hempelian model of explanation is offered, it's not long before a student says, well, for goodness sake, what hubris, what absolute arrogance, how could you ever know that a law is true? You might always be mistaken. After all, our species is the species of fallibilists, isn't it? We might always be wrong. And to this, the stock reply, the Hempelian reply, is this. You've tested this in every imaginable way. You've submitted the law to experimental confirmations and refutations and the like. It has succeeded every test. What could you ever mean by something being true, except that every attempt to falsify it has failed? That is, as of now, the only basis you have for ever declaring anything to be true is satisfied by these tests, and so you take these tests to be true and to satisfy the condition that the law be true. Now, this is one model, and if we apply that model to the discipline of psychology, the answer to the question, are the textbooks right, is psychology a science of this or that, the answer is, and I want to state this firmly and dogmatically, yes and no. The answer to the question is yes in some subsidiary fields of psychology. As you will see in subsequent lectures, in a field like sensory psychology, visual information processing, basic sensory processes, to some extent certain aspects of learning and memory. In areas like this, there are quite reliable statistical laws that permit one to make fairly accurate predictions. As we move more in the direction of psychoanalytic theory, theories of personality and the like, this degree of predictability fails. And so the more realistic and lifelike, and I should say deeply interesting questions we confront in psychology, the kinds of questions that routinely get people interested in psychology, the less we are in possession of reliable statistical laws or anything that would look like, in the Hempelian sense now, a scientific explanation. So, as the ancient Greeks knew, for every blessing conferred by the gods, there are two curses, and the way that matches up with what I've said so far is this. The more interesting the psychological question, the less precise we can be in answering it. The more precisely we can specify a general law in psychology, by and large, the less interesting is the phenomenon. At least most people would judge the phenomenon in question to be not of the greatest degree of interest. Now, that gives us one approach to the subject of psychology. We should be aspiring to develop general laws. We should conduct experiments and gather data and make measurements and try to render ever more precise our predictions, ever more precise our measurements, until finally we are in possession of ever more general laws that will include such things as interpersonal influence, personality, emotion, love, bonding, all the things that fill out the pages of such learned journals as Time Magazine and U.S. News and World Report and so forth. Well, there's a counter to this. There's an argument to the effect that not only is this not a worthwhile undertaking, but it's an entirely misguided undertaking. That is to say, there's an entirely different tradition, what might be called a humanistic tradition, that would identify psychology as precisely the sort of subject not fit for scientific development and for evolution into a scientific and systematic body of knowledge. Now let me rehearse some of the arguments behind that view. We might begin by asking, what is it that makes an event psychological in the first instance? That is, how would you distinguish between a shoe falling toward the center of the earth and, let's say, Smith driving to work in the morning? Now, if you just stay at the level of folk psychology or folk wisdom, which I shall argue throughout this course is not a bad guide after all, if you stay at the level of common sense, the difference between a shoe dropping toward the center of the earth and Smith driving to the office in the morning is just the difference between something being obedient to the fixed, immutable laws of physics and something else having certain volitional powers, certain autonomy, a certain freedom of action based on deliberated choice, prudential judgments, the need to earn a living, the fact that the boss is going to complain if you're late, happily discovering that the car was filled with petrol the night before, the highway isn't clogged, and you think you can get there in time to have a coffee and perhaps even a biscuit. None of these things has to be considered when it comes to shoes falling toward the center of the earth, and they always have to be considered when it comes to things like Smith going to work in the morning, or Napoleon losing in Belgium at the Battle of Waterloo, or presidents giving State of the Union addresses, or the determination to move to a different neighborhood because you think the school systems are better. That is to say, it has been argued that what makes an event psychological in the first instance, or for that matter social, or historical, or economic, is that the event only takes place through personal agency, through the plans and motives and aspirations, the desires, the reasonings and reflections of actual beings who are free to do otherwise and who have to be understood in their own unique terms. It has been argued, for example, that events that are genuinely historical, first off, happen one time only. You can't do an experiment on Napoleon's losing in Belgium's. It doesn't happen often, so you can't take repeated measures. There can't be a general law that covers a singular event. Moreover, the persons who actually flesh out history, create autobiography, create interpersonal relationships, create, now generically, psychological phenomena, can't be substituted for. You can't say, well, forget Napoleon, we'll just put somebody else in there who tends to keep his hand inside his jacket, is rather short, and has a three-cornered hat on. You also know the difference between a motion picture that seeks to feature Napoleon and what actually happened in Belgium in the first quarter of the 19th century. Now the argument generally then is this. For an event to be truly psychological in nature, truly social in nature, or historical in nature, It is not reducible to general laws. It is not a repeatable event. It is unique in and of itself. The participants cannot be substituted for. And ultimately, the best explanation of events of that kind is by way of examining the motives, goals, aspirations, and perspectives of the participants, to view all this within the larger context of history or biography, social life, customary practices, cultural values, and thus the scheme to try to find some universal law of gravitation here is not only doomed to fail, it's the wrong project. That in fact, if you could reduce some significant human enterprise to a general law, it would have to be because that enterprise itself was in some rigid sense determined, the way physical events are, and this would precisely strip them of their psychological or historical or social attributes in the first instance. Well, what does this tell us then? First, I think when it comes to consequential questions, we should always answer them not with exclamation points or periods, but with semicolons. This is part of the long debate. It goes on even as I stand before you. There are agile wits dealing with questions of this kind, and I should say that this is not an area in which there are right and wrong answers. This is an area in which a variety of perspectives can be defended with more or less vigor and in more or less convincing fashion. Now, at least this far, we see the possibility of two quite different psychologies. A scientific psychology, or psychology aspiring to scientific status and occasionally reaching it, that is very much process-based. The focus is not on the individual, it's not on interpersonal relations, it's not on complex social phenomena, it's not on the role of the person in history, the role of the person within culture. It's not on that at all. It's on such things as, just to cite a number of examples, color vision, reaction time as a function of the intensity of a stimulus, the number of times one must rehearse a list of things in order to be able to commit it to memory accurately, the extent to which changes in the biochemistry of the nervous system alter mating practices or maternal behavior in non-human species, the effects of significant lesions in the brain on the ability to speak or to understand the spoken word or to understand the written word, the possibility that a small lesion somewhere in the brain, in this particular case I'd mention in the core of the temporal lobe of the brain, can find the victim performing very complex acts, often destructive criminal acts, involving assaults and assassination attempts, which that person is totally amnesic of at a later time. Yet the behavior looked entirely purposive. It involved planning. It may have taken place over a long period of time. It's a bit of behavior that this person engages in with some regularity, and when that small space-occupying mass is removed, to use a high-tech term, when the calcified glioma is surgically removed, there is never again a recurrence of activity of this kind. And so we'd say here we have evidence of something that certainly looks intentional, looks planned, looks to be the product of goals, motives, aspirations, and the like, but seems instead to be determined by nothing less than a tiny pinhead-size calcification that just happens to be in the worst possible place. Now, some have argued that evidence like this, evidence from clinical neurology, from studies of non-human animals, studies involving brain surgery and alterations in the electrical and chemical properties of the nervous system, have made abundantly clear that you can get the widest range of behavioral changes, social interactions, conduct within a social context. You can achieve almost any desired change by systematically altering the properties of the nervous system, chemically, electrically, surgically. Therefore, why would anyone argue that at the end of the day, psychology will not be a deterministic, nomological, deductive type science in which you explain even the most subtle, complex, and various features of human life by reference to the chemical, physiological, and biophysical aspects of the body in general and the brain in particular? We shall be weighing arguments of that sort and returning frequently to the question of whether a deterministic model is the right one for psychology, or what might be called an autonomist model, in which you understand complex psychological phenomena only by assuming freedom on the part of the participants to determine what their own goals are going to be and how they will set about attaining them. I should say in this connection that it's entirely possible to predict someone's behavior without at the same time adopting a deterministic perspective. For example, if I shall do an experiment right here. I won't actually gather much data, and I doubt we'll be able to publish this one, but let me try it. I would just like those here who are female to raise their hand. If the females in the room would just raise your hands. All right. Now, I was able to predict with unfailing accuracy the number of hands that would go up. In fact, I could even identify the persons whose hands would go up. Nonetheless, it would be preposterous for me to say that because I could predict all that, your actions were totally determined and beyond the reach of your own free will, your own desire, your own willingness to cooperate and collaborate. I say this so that it becomes quite clear at the outset that even when psychology can predict behavior, that doesn't necessarily mean that the behavior thus predicted is in fact rigidly determined the way shoes falling toward the center of the earth might be an event that, and is indeed an event that is rigidly determined. The reason I knew which hands were going to go up is because we are part of a common culture. We have a set of shared values. We have understandings that are based on the nuances of the language that we speak, the rearings that we've had, the attitudes that have been formed in the course of a lifetime. And it's because each of us can enter into the mental life of another, empathically, we say, or sympathetically, that of course we very often can predict quite accurately what another is going to do. When someone very, very close to you comes in sporting some new item just fetched from one of those very smart shops and says, well, now, how do you think this looks? You know to a moral certainty that if you reply, or I should say mediocre, that the response to that is quite predictable. If you say, couldn't be more stunning, it'll go down in legend and song, that's going to elicit yet another reply. This is just to say that life together becomes predictable because of these shared values, this cultural immersion in which all of us locate our lives. Predictability is not evidence for determinism, though it is a talking point for determinism and a deterministic psychology. Well, anyway, much of this becomes clearer as we proceed through the various topics in the course, and we will see much evidence supporting an essentially nomological deductive view on the nature of psychological research and explanation, and of course we'll see very much on the other side, which goes by several names. It's sometimes called hermeneutics, in that what's required is a kind of interpretation. Sometimes it's called a narrative approach. You explain something by locating it within a story, and we'll be using these terms selectively and also interchangeably in lectures to come.